Okay, we will continue with January 2013 and start with number 14. Be careful on the subtract. When this group is subtracted from this, 3 is subtracted from 5. You say 5 minus 3. So you're going to subtract up so that this is the first one. X cubed plus 3x squared minus 2x minus, and you must put parentheses around this grouping that you're subtracting. You're not subtracting the first term, you're subtracting the group of them. So distribute your subtract sign. X cubed plus 3x squared minus 2x minus x squared minus 3x, be careful of the last one, plus 4. Now, collect your like terms. You've got an x cubed. You have a 3x squared minus a 1x squared. You have a 2x and a negative 3x. And then you have a plus 4. So that should be your first answer. In number 15, this is a nice example of your unit circle. Your unit circle says your radius is equal to 1. Therefore, this is a radius right here, where your hypotenuse is of your triangle. That is equal to 1. Now, your sine of an angle says y over r. Well, if the sine is y over r, and the r is 1, then on a unit circle, the sine is equal to the y. And the y value in this case is the segment TS. Remember, this happens on a unit circle because your radius or your hypotenuse is 1. In 16, this is an area of a triangle. Since they do not tell you that this is a right triangle, don't assume it is. Just draw a triangle and label it A, B, C. So your area is 42. If AB is 8 and the measure of B is 61, you need to find the measure of BC, which, remember the letters, the little letter is across from the angle. So we need to find the measure of BC, which we'll label A. Now, you have a formula on your formula sheet for an area of a non-right triangle. Your area formula begins with a K. You've got 1/2 AB sine C. Notice these 3 letters are different. So if your angle is B, you want the other 2 letters right here, A and C. Then just plug it in. 1/2, I don't know A, I know C is 8, and I know the sine of 61. And I know my area is 42. So you can do all of this, approximate it into 3.5A, and then divide by 3.5. And A is about 12. So somewhere right over here, and there's your 12. They're far enough apart that you didn't have to worry about the rounding in this area too much. This is a factored completely. First of all, I would get rid of this number 1, because that's not factored completely. And anything else you see that is not factored completely. So we're okay with those, and let's continue to factor. Now, look at all of them. They don't contain an X. They don't all contain a 3. So to do this, we're going to have to group. Group the first 2, group the last 2. So out of the first 2, you can factor out an x squared. You're left with 3x minus 5. Now your goal is to get that out of there. Notice the signs are different. This is a negative, this is a positive. You're going to divide out by a negative. And what they share in common is a 16. That will give you what is left, 3x minus 5. From here, we have a common factor, and we have the factor that's left, x squared minus 16. Now notice that one's here, but it's not factored completely. To factor it completely, you've got to factor your perfect squares in here. And don't forget to keep this factor. Now, if you struggle with this, another way to do this is to take this guy and put this in your y equals, in y1. And then to take each one of these and put this in y2. All you did was get the factors. You did not change the equation. So when you graph this, it has to be the same graph. That's one way to do it. Another way to do it is to work yourself backwards. Notice this and this have this. So maybe this one was good, maybe it's these two. This is your x squared minus 16. Multiply it by this one first and see if it brings you back to that. This one I'd stay away from because x times x times x times x is x to the fourth. So is this one. That's x to the fourth. You only go as high as x to the third. So therefore, it can only be choice 3, even without us working it out. Okay, number 18. Number 18, if you recognize this, this is your formula for the sum of two angles. You have a sum formula and a difference formula in the back. So your sum formula is equal to the sine of A cosine of B plus cosine of A sine of B. Now, 180 is A. So find the sine of 180. You can do it on your calculator or you can do it on your unit circle. The sine is y over r. Find the cosine of 180, -1, and substitute those in there. So 0 times the cosine of b, because we don't know what b is, that's your x value, plus the cosine of a, which is -1, times the sine of b. This wipes out. This is equal to negative sine b, and we used x instead of b. Okay? This next one gives you two radicals, and even though they're cubes, they work the same as squares. If you struggle with your radicals, my advice is to make a list of radicals. 0, 1, 2, 3. Just string out a bunch of these and then cube them. 0 cubed, 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, and keep on going with this until you get to where you want to be at. Now, if you notice, let's do one more here. This is 6 cubed. So we're past this. If you notice, your 162, where that's going to fall, and where your 6 is going to fall. So you can tell what your cubes break down. Your cubes break down the same way your square roots break down. Only they break down into perfect cubes versus perfect squares. And you're summing these.
Test 1, 2.
This is going to break down into a perfect cube and a not so perfect cube. Well, we can see 6 doesn't have a perfect cube. That goes here. Take your exponent and divide it by this index. So 3 does not go into 4 evenly. So I drop this down to a to the third. That's divisible by 3. And the leftover 1, 3 minus 3 from 4, I'm left with 1 left. The b squared, I can't even fit into a 3. That's left over here in your imperfect one. When you take the cube root of a, divide your index into your exponent, a1. Left over. You're adding it to this guy. Do the same thing. A perfect cube, a not so perfect cube. When you look for 162, you will have to say, go down here, does 125 fit evenly into 162? Does 64 fit into 162? Until you find the 27 fits in. 27 times 6. And we also want it to look like this. And look it's got the same exact exponents. So we knew this was a cubed, a left over, b squared. Take the cube root of 27, which is 3, cube root of a cubed, which is a1, and you're left with the same radical. Once these radicals are the same, you add 1a plus 3a. You get 4a and the cube root of 6ab squared. And that's your answer. If you struggle with this, you can pick a value for a random value. Don't pick 0, don't pick 1. Make a be 2. Make b be 3. Plug it into both of those and add them up, and then find out which sum represents the same one. It's another way to do it, but not the best. Now, here we have a graph. It's either going to be a sine curve or it's going to be a cosine curve, because we notice these angles. We notice that this one, 3 goes into 180 60 times, and this one is at 120. So you have one complete cycle of some curve before it dips down again. This is one complete cycle. So your frequency is 1 over here in 120 degrees. So if my cycle is out of 360, then my frequency, therefore, is 3. My period, let's make this my period. My period is 120. It takes 120 degrees to complete one cycle. I have 3 120s in 360. There's my frequency. My sine curve, start with your 0. Do a cosine of 0, which is 1. Do a sine of 0, which is 0. My sine would have started here. My cosine would start here. So notice the amplitude change. It was amped by 2. So my amplitude is 2. I have a cosine curve, and I have a frequency of 3. So from there, I can figure out my curve is y equals 2 times the cosine of 3x, which is your first one. Get rid of your sines to start with. This one, it took that period and stuck it in here. This is the period, not the frequency. This should be b, which is your frequency. How many curves do you have in 360? Okay, for 21. 21 is it varies inversely. And as soon as you see varies inversely, you say product. The product of one set has to equal the product of the other. Now look, they use p's and q's. So p1 times q1 has to be the same product as the second set. And just plug them in. p1 is 20 when q1 is negative 2. If p is x, when this is negative 2x plus 2. So just work this out. Not as simple as just one that we find in Algebra 1, but it's the same principle. Negative 40 is equal to negative 2x squared plus 2x. Notice the quadratic, get everything to one side. I'd move these to the right. Keep this x squared to be positive. So you've got 2x squared minus 2x minus 40. Divide everything by negative 2. Make your life easy. And factor. So x is equal to negative 4 and x is equal to 5. And that's this one right up here. Okay? The next one jumps back to a trig. Sometimes it's helpful to go through one Regents and do all the trig problems, get them out of the way. If you're going to make your unit circle and you're going to find all your formulas for your trig, get all your trig problems done at the same time. Then circle back through and do another type. We want a solution set, and we want that solution in degrees from 0 to 360.
Deputy Clark, please report to the main office.
So-
Deputy Clark, please report to the main office.
Isolate your variable, your secant of x. Divide both sides by this. You have a secant of x equal to 2 over this. Now, if you are looking at this, you have a couple of ways to do this. You can take its reciprocal, make it a cosine, take this reciprocal, make it radical 2 over 2. Sounds like a 45-degree angle, right? With a negative. Cosine is negative in 2 and 3. This will be a 45-degree angle. It actually came from this, and it was just rationalized. So find your reference angle, and you're going to either be in this quadrant or in this quadrant. This one is 180 minus 45, and this one is 180 plus 45. My advice is that you learn your two special angles. A 45-45 says 1, 1, radical 2. Both the sine and the cosine are 1 over radical 2. Number 23 gives us a discriminant. A discriminant is that part of your quadratic formula that sits right under this radical sign. So b squared minus 4ac is your discriminant. They gave you the discriminant as 24. Put it under the radical. Is that a perfect square? No. But is it real? Yes. So I've got a real, not imaginary. Being that it's not a perfect square, it's irrational. All that has to do is describe your roots. That's all you wanted to do. Okay? Here's a probability one where something repeats. How many different 6-letter arrangements can be made using the letters from tattoo? There are a total of 6 letters. If you did 6 factorial, or 6 times 5 times 4 times 3 times 2 times 1, you're a little off because changing a T, it would still be the same word. Changing a T again would still give me the same word. So what you have to do is take your 6 factorial and you have to see what letters duplicate. I have 3 T's and I have 2 O's. So take this and put 3 factorial and this 2 factorial. Now if you put this in your calculator, remember to put that part in parentheses, or your calculator will give you a different answer than what you anticipated. And that will give you 60. Take out your duplicates out of that one. Okay, here we have, we're adding a fraction. Now you know in fractions, if the denominators are the same, you can add the numerators. These denominators are almost the same. If I factored out a -1, they're completely opposite. It would exactly look the same. This negative, you can move in place of that, just to make your life easier. Because it's plus a negative, so that's your subtract. Now, my denominators are the same. So keep a common denominator, pull the numerator over, and see if it can be factored. Sometimes you can factor it and sometimes you can't. I would look first to see if it's factored. Now they say they want it in simplest form, so make sure you factor it, because what happens is sometimes it is there, and it is, but this has to be factored again. Take out a 3, factor out a 3 in the numerator, factor out a 2 in the denominator, and then take out your common factor. In simplest factored form, this is the answer. Don't fall into that trap just because you see it there. In number 26, we have log substitutions. Your rules of logs are like your rules of exponents. In exponents, if you're dividing, then you subtracted your exponents of like bases. So turn this one into a subtract. And because you're using 2's and 3's, you want to get this down so that you can get a 2 or a 3 out of here. This one's kind of obvious because this is your 3 squared. Your rule again is bring down the exponent. That's your power rule. This one's a little trickier. 20 actually breaks down into 10 times 2. Well, the log of 2 they give us. The log base 10 you can do on your calculator. Logs in 10, base 10, is the exponent of your scientific notation number. So 10 is 1 times 10 to the 1. There's your exponent. The log is your exponent. So if you can break this into the log of 10 plus the log of 2, we can do 10 times 2, and we know in a multiply you turn it into an add. So the log of 10 is 1, and the log of 2 is A. The log of 3 in here is B. So 2B minus, and I would distribute this, parentheses, distribute this negative, and see if you find it there. Don't fall into taking number 1 because you needed parentheses around that. Be careful of that. The next one is using your complex number. My advice is whenever you get started using a complex number, put these out. It's a pattern. If you don't see the pattern, put it in your calculator. Put in I to the 0, that's 1. I to the 1, 1. I squared, negative 1. Put in I cubed, negative I. You need to know those. Now, perform whatever it is it asks you to perform, but watch that negative sign. This says do x plus I times x plus I. This says do x minus I times x minus I. So when we FOIL these guys out, we get x squared plus 2x plus I squared minus, in parentheses, x squared minus 2xi plus I squared. Now, I squared is negative 1. Replace the I squareds with negative 1. Okay, just replace them first. Now, come through this and distribute your negative. That's 1. And collect your like terms. Notice that your x squareds cancel out. Notice that your 1's cancel out. And you've got a 2x, and that cancels out, oops, oh, 2xi. Sorry about that. A 2xi in here. I forgot the I. And your 2xi's are going to cancel out. Or going to add up to 4xi. They're not going to cancel out. They're going to add up to 4xi. So let's just hit this again. When we FOIL this one, we should get x squared plus 2xi plus I squared. And you can even leave the I squareds in there because the I squareds are going to cancel out anyway. Minus x squared minus 2xi. size scale. When you bring them over and you distribute your negative, everything should cancel out except for your 2xi and your 2xi. That'll give you your 4xi. Now this concludes the part 1s. Part 2s we'll work on in the next group.